Standard 8115, express approximations of very large and very small numbers using scientific notation. Understand how calculators display numbers in scientific notation, multiply and divide numbers expressed in scientific notation, and express the answer in scientific notation using the correct number of significant digits. This is a big one. When physical measurements are involved. So here we go. Scientific notation, in a nutshell, is basically a way of writing very large and small numbers using a number between 1 and 10 multiplied by a power of 10. Here's an example when I multiply two things that are in scientific notation. Both those terms are in scientific notation. Basically what happens when you multiply terms together that are in scientific notation, you multiply the numbers. Once you multiply the numbers, you go ahead and you can add your exponents here. So 10 to the 4th, 10 to the 3rd, well, you're going to get 10 to the 7th, right? Well, 4.2 times 8.25, you're going to get a number that is larger than 1 and 10. So what happens in the end is you wind up with 3.465 times 10 to the 8th. Significant digits states that when you are describing a precise thing, and it needs to be written precisely, particularly when numbers are a measurement, or when a number is described as a measurement. So if I use the same example above, if I use this example, and we're saying that this example is talking about miles, if this was talking about miles, that is a measurement. So significant digits basically go along the lines of this. If you look at this example, okay, I take the same example listed above where you had this answer in scientific notation. Since it is a physical measurement, the answer should be expressed as 3.5 times 10 to the 8th. So look at here, basically what happens is it's rounded. Now, to determine how many decimals you round to, it all regards the first factor. Okay, the first factor is 4.2. Notice that 4.2 has two significant digits. It has the lead digit followed by the second one, so 1 decimal point. So it has two significant digits, therefore you would need to round that answer to 2 significant digits. Example 1, find the product of 2.5 times 10 to the 3rd times 6 times 10 to the 5th. Write the product in scientific notation. So two scientific notations here. I'm multiplying, so I'd probably start off with multiplying those numbers first. Then I would go ahead and take my exponents here, 10 to the 3rd times 10 to the 5th. When you multiply, have the same base, you add exponents. So I would wind up with 15 times 10 to the 8th. Answer's not done yet. Reason being is this number right here is not in scientific notation. That is not between the 1 and 10 there. So I'm going to take 15 and convert 15 into scientific notation. 15 in scientific notation is 1.5 times 10 to the 1st. Now you're basically combining your answers here. What happens is I don't have 15 anymore. I have 1.5. I'm going to take my 10 to the 8th times my 10 to the 1st. And when I do that, I add my exponents, and I get 1.5 times 10 to the 9th power. The next thing that they're asking you to do is write it in standard form. Standard form is the answer. So basically what's going to happen is you're going to start with 1.5, and 10 to the 9th power is really saying 10 times 10 times 10 9 times. So you're going to get a larger answer. So you're going to move your decimal to the right to get a large number. When I move it to the right, I move it 9 times. After I move it 9 times, I come up with my answer in standard form, which would be 1,500,000,000. Next, the planet Earth is approximately 93 million miles from the Sun. What is the number in scientific notation? So first off, I'm going to take my number here in standard form, write it out, throw my decimal point in there. When I do that, I need to figure out how many units I need to move. There's 2, 3, 4, 5, 6, 7. So I have 9.3 times 10 to the 7th. And another reason, remember, I have to get back to 93 million. So it's not negative 7 there, because 10 to the 7th is, again, 10 times 10 times 10, 7 times there. So when you multiply that times 9.3, you'll get a big answer there. So our answer here is B. Example 3, the thickness of a penny is about 6.1 times 10 to the negative second inches. Which of the following is equivalent to the to this measure? So what I would do is I would actually take this example, 6.1 times 10 to the negative second. Now if you think about this, most people might know where to go right away. If you don't, convert this exponent into a fraction to get rid of the negative exponent. Remember, this has the negative exponent. This would move to the bottom. You would now have 6.1 times 10 to the negative second would move to the bottom, to the second. So this is really saying 6.1 times 1 over 100. Therefore, your answer would get smaller. So that's just telling you that you need to really move it to the left 2 units. And when you move it to the left 2 units, you would find out your answer here is B. Last example, a calculator displayed showed 3e to the 6th. This represents which of the following expressions? All this is telling you that is your exponent is 6. So when your calculator displays scientific notation, this first number here is the number between 1 and 10. You know it would be times 10 to the some power. And this is telling you that, again, that exponent is 6. So this would be our answer here, C. This will conclude 8115.